and you're able to at least watch this once more if you need to. All right, so let's get into it. In year 11, remember there are, I think there's a total of 4 topics plus a bunch of little mini sort of topics that we'll get into. But what I really want to focus here now is this concept of your rounding and your significant figures and decimal places. Because in year 12, this is one of those things that if you don't do it properly, for each question you might lose half a mark. Okay, which is a lot already. Say, for example, the question says, okay, you have a number that's like 932.567, and it says, I want you to round this to 2 decimals, and you leave your answer as this. Yes, this is correct, but because you wrote it to 3 decimals instead of 2, you'll get -1 mark for it. Okay, or you'll get half a mark taken off you for it. Okay, so you want to make sure, okay, that with this, okay, that you actually do the exact rounding, or if it asks you to actually, approximate something properly, that you do it. Okay, that you don't want to skip on that because that's already half a mark that you've lost. All right, so in year 10 and 8 and 9 and whatever year levels, you would have learned at some point how to round your numbers, okay, how to approximate numbers. All right, so let's do some rounding here. And so some rules for rounding that you need to look at, okay, is obviously look for the number of digits it tells you to round in. So if it asks you to round to 2 decimal points, round to the nearest 100, nearest 1,000, those sort of things, okay, read that properly. Okay, make sure you understand what it's telling you to round to. Okay, now what it says here is look to the right of the digit of the specified. Look to the right of the specified digit. What that's saying is, if you say you've got a number that says 367,015, okay, and it's asking you to round it to the nearest tenth, okay, which means that you need to round it to this number. This number on the right, so you always got to look at the number on the right because that will influence that last number that you're rounding to. Okay, so just watch out for that. If the value, remember, if you have a number, okay, if you're going to round and the number to the right is 5 or above, then you're going to round it up. Okay, if it is 0 or below, then you just leave it. Okay, so there's no decreasing the number, it's just you put it up or you just leave it as it is. Okay, let's look at this. Round 34867 to the nearest 1,000. Okay, so 34,867. Okay, this is where your primary school knowledge will come in. Can anyone tell me what each of these units are going to be? These are your what units? Your ones. These are your tens. Good. These are your hundreds. Bad writing. These are your thousands. Okay, so that means if I want to round this to the nearest 1,000, wow, you guys are smart. Okay, we're rounding it, so we're going to focus on stopping at this number, okay, in terms of what we're going to put in. So if you think about that, nearest 1,000, look at the number to the right. I can see that it's an 8. So that means when I round this bad boy, okay, it's going to be 3, and that 4 becomes a 5, okay, and then the rest becomes 0. Okay, because, again, you look at the number on the right, that influences whether that goes up or down. So for that first question, rounding it to the nearest 1,000, okay, is 35,000. Okay, easy. Again, you can watch this and look at the example if you are a little bit lost, but this will be put up in OneNote. Okay, if I ask you to round this to say the nearest, let's say the nearest 100, what would it look like? So if you're looking at the hundreds, it's this unit, so you have to stop here at that 8. So it's going to be 3, 4. The 8, okay, have a look at the number to its right, which is this guy. It's a 6. So that means this 8 now becomes 9, and the rest becomes 0, okay? That's if you wanted to round it to the nearest 100. Okay, let's keep going. Okay, now this is some of the year 11 content that you may have not done yet. Standard form or scientific notation. In year 11, you'll come across, actually, you don't really do a lot of this in year 11, it's more so in year 12, but you will come across this, what we call scientific notation. And this is when you're working with very large or very small numbers. Okay, either large or small numbers. And when we're talking about large or small numbers, you're looking at numbers that look like this, or decimal numbers that look like this. Okay, so scientific notation works with large or small numbers, and the idea behind them is you want to write the numbers in a certain way so that it's easier to represent. So instead of, okay, I ask, Matt to say, all right, Matt, I want you to write 10 billion, all right, the number 10 billion. What would that look like, Matt? You know what 10 billion looks like? So it's 10, yep. And how many zeros? Good, 9. Okay, that took too long for me to do. Okay, as a mathematician, you want a short way of doing that. Okay, so this is where scientific notation comes in. Okay, so the idea behind your scientific notation is your numbers, okay, should always look something like a decimal. Okay, so it should look something like this. A decimal times 10 to the power of something. Okay, this is the basic principle for your scientific notation. So it's always going to be a decimal times 10 to the power of whatever that number is. We'll call that x for now. Okay, so this is what your scientific notation will always look like. Decimal times 10 to the power of something. So if you look at, for example, this number here, which is, how many zeros is that? 1, 2, 3. So this is 249 billion. If you want to write that in scientific notation, it's going to look like this. Okay. Now, in terms of, okay, how do you get to that point? Okay. Remember, it should look like a decimal. Okay. The first number should look like a decimal. So what I do is I look at this number, 249,000,000. Okay. And you always want to make sure that in the first number in your decimal is just going to be just a ones unit. You don't want to make it 24.9, for example. You want to make it 2, so one number, point, the decimal, and then the numbers after that. Okay, so start off with that. Now the next part is having a look at where the decimal is going to go, okay, is important. So if you put your 2 decimal point here, okay, the next thing you do is you count the number of spots that decimal moves to the very end of the number. Okay, this sounds a bit complicated, but we'll do a couple more examples of this. So if you look at where that decimal point is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That decimal point gets moved 11 spots. So the next number is going to be 10 to the power of 11. This 11, okay, tells you how many points or how many spots the decimal point moves to the right. Okay, see how it's positive 11. Positive meaning it's going to be moving to the right. Okay, let's try another one. Just as an example, let's say you have this number, and I would encourage you guys to write these examples if you want to, but let's say you have 3, 7, 6, 5, and then you have like, I don't know, 1, 2, 3, 4 zeros. Okay, let's start with that. This is my number. Okay, so with a number like this, okay, you want to put the decimal point just after that first number. So it's going to be 3.765. Okay, times 10, and then to figure out that power, okay, look at that decimal and see how much it moves to get to this point here. So 1, 2, 3, 4, 5, 6, 7. So it's 10 to the power of 7. So that's my scientific notation for this. Let's try another one. Let's go like 4720000. Okay, so for this, put your decimal number, okay, right there after that first number. So it's going to be 4.72. There's your first, times 10. Again, and the power will depend on how many times you move that decimal. So 1, 2, 3, 4, 5, 6. So to the power of 6. Okay. Now that's for large numbers. How might that work for your smaller numbers? Okay. For small numbers, it's a similar principle. Okay. So have a look at your number, whatever the decimal is, and put the point next to the first number where it starts, where the zeros finish. So if you got 00000, and then you have your first number, put that decimal point there first. Okay, put the decimal point there first, and then from there, because it is a decimal, okay, you're going to count backwards. 3, 4, 5, 6, 7, 8, 9. Backwards to where the decimal point first began. Okay, so let's say, for example, I'm going to write my own numbers for this. Let's say you have the number 0.0000237. Okay, so this is my small number, and I want to put it into a scientific notation. So put your decimal first, where the first number after those zeros begins. So there's my decimal there. So your first number is going to be 2.37 times 10 to the power of, okay, now, because we're going back the other way, okay, it's going to be a negative power, okay, because we're going the other way instead of this way. So you just count the number of times you go back to that normal or the original spot. So 1, 2, 3, 4, 5, 6. Oops, sorry. Let's fix that up. 1, 2, 3, 4, 5, 6, and back to this point. So it's going to be to the power of negative 6. Okay, one more example. Let's go 0.00000000210. Okay, let's go with that. Okay, and let's, okay, so the first thing you need to do, put your decimal point right after the first number that's not a 0. So right there. Start with that. Okay, so your first number is going to be 2.10. Now, be mindful of how I kept that 0 in here. Okay, because that's going to be important. You don't want to skimp on that 0. You got to keep it. So keep that 0 in there. So keep that 0 times 10 to the power of, okay, now count back to where the decimal point initially was. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So to the power of negative 9. All right. So that's that. All right. Let's see if you guys can do these. So I want you to write these in scientific notation, just these two, and then we'll finish up.